Welcome students to the SYBSc program in electronics. That is semester 4 and our course code is ELC 104, course title microprocessor and microcontrollers. We are doing the unit 6, that is 8051 IO port programming, and today we'll be doing the actual programming of the IO ports using assembly language. Myself, Mr. Kenneth Shinlobo, ex-faculty member of St. Xavier's College, Marsa, Goa. Outline of today's module. Okay, we'll be just giving a small intro about what is IO port programming, and then we'll be looking at programming the port 0 and port 1. And finally, we'll be looking at a small delay program which have been used in the programs which we have done for port 0 and port 1. By the end of this module, you'll be able to write simple coding using assembly for port 0 and port 1. So let's get a brief idea. First of all, we'll just revise what we have done in previous modules, that 8051 has 40 pins, out of which 32 pins are used for IO ports, and there are 4 ports. Okay, there are port 0, port 1, port 2 and port 3. And each pins are bidirectional and can be addressed individually. Upon reset, all the ports are as input. Okay, so whenever you reset a microcontroller, 8051 microcontroller, all the ports will be input ports, okay, that it will be getting data rather than giving out data. Fine. So if I want to make it as an output port, I'll have to write it with zeros. Okay. So that we have seen in our previous modules. So let's get to IO port programming of port 0. As you all know, port 0 has to be connected with an external pull-up resistor. Why do we do this? We do this because the output of port 0 is in the floating state. What do you mean by floating state? It means that both the MOSFETs are unsure whether to go high or whether to go low. So they are floating between two values. So in order to get them into one particular high value, we have to connect an external pull-up resistor. So you all can see in the diagram that the pull-up resistors are connected to each and every pin of port 0, and they have to be supplied to VCC because I have to pull them to high state. High state means logic 1. And the port 1, port 2 and port 3, they do not require external pull-up resistors. So please keep this in mind. So let's look at a basic program, okay, that is written in assembly language. So the following code will continuously send out to port 0 the alternating values of 55 and AA. Okay. So why we chose 55 and AA? So what is 55 in binary? So 0, 1, 0, 1, 0, 1, 0, 1, right? That is 55 in binary. And AA is what? 1, 0, 1, 0, 1, 0, 1, 0. So this is the values of 55 and AA. So these values, if we choose these values and if we alternate between these two values, it will be looking like, okay, first this guy is on, okay, then for the next particular time, it will go off, on, off, on, off. So you'll get a sequence or series of blinking structure or a blinking sequence. Okay, you'll get a blinking sequence. So how do I write this particular code? Using my ports. Okay. So first part is very important. Always make the port as output because I want to send data. I don't want to receive data. I want to send data. So always make the port as output. How do we do that? I'm going to move 00H into port 0. Why do we put a hash? Hash is put in order to indicate that this is data. If I don't put the hash, it indicates it is an address. Okay, please note. Hash indicates data. Okay, if I don't put a hash symbol, it indicates address. So port 0 will be storing the address rather than the data. And this type of addressing mode, okay, is called as direct addressing mode. Why direct addressing mode? Because we are directly transferring the data into the port. So first of all, we have configured port 0 as an output port. Next thing, we are going to put the value of 55 into the accumulator. Okay, I'm moving the value of 55 into the accumulator, and from the accumulator, I'm moving it into port 0. Now, why I'm doing this? What type of addressing is this? This is called as a register addressing because I'm storing in a register first, and from the register, I'm going to put it into a port. So this is a register mode addressing. Then I will call a delay. So there's something called as absolute call. I will talk about it when we go to the delay part. So there is absolute call. And then after a particular delay, after particular waiting, I will transfer the AA data into the port. Okay, I will do it in the same manner how we did it for the first part, that is 55A. So we are going to put AA into A. Okay, that is the accumulator. And then from A, that is from the accumulator, we are going to put it into the port 0. Okay, so don't get confused when I say A and AA. Okay, so A means accumulator, AA is the data. Okay. Then again we call for a delay to hold that particular value for some time and then repeat this loop. Okay, so we get some blinking sequence. So this is how the output will look like. So if you notice, the output is jumping between 55H and AA. Okay, so first you get 55, then you get AA, 55A. So a very simple program to use port 0 as an output. Okay, so we have written one code wherein we are taking some data internally and we are going to give it as an output through port 0. Now if you notice, we have connected resistors. Okay, what is the value of this resistors? 10K. Okay, I'm sorry I did not put the values over here, but please note down that values of this resistor is 10 kilo ohms. And these are red LEDs. So if you notice, red LEDs will have a potential difference of around 2.2 volts. Okay, so 10K is sufficient amount. So this is an program to write data or to give out data through port 0. Now, suppose if I'm using port 0 as an input port. Okay, so in order to use as an input port, so let's look at the problem statement. Port 0 is configured first as an input port by writing 1s to it, and then the data is received from port 0 and sent to port 1. So let's see. So first we have to make it as an input port. Okay, port 0 is made as an input port. So I have to write it with FF. Now please note that you have to put a numeric value whenever you have an alphabetical value. Okay, so you have your hex values are going from 0 to F, right? So you have A, B, C, D, E, F. Now in order for the compiler, okay, to understand, or basically when we are doing assembly, it is an assembler. Okay, so whenever you are writing the code, the assembler has to understand that you are giving some data. So in order to do that, in order for the assembler to understand, I have to put a 0 whenever you are giving an hex value. So if the first part is an alphabet, then you will have to provide a 0 before it. For the assembler to understand that this is data, hash value is required. That is the main part. Okay, but only if there is a alphabetical value, then you will have to put an extra 0 in the data part. Suppose it is an address, you don't require. Okay, for address it is not required. Address, suppose this was an address, then I don't put the hash, I don't put the 0 as well. Okay, it will understand that this is an address. But only for data, we'll have to do this. Otherwise, we'll get errors in the programming. Next part, whatever data is given to port 0. Now we are making port 0 as an input. See over here, this is given to the accumulator, from accumulator to port 0. I can directly do 0FF into port 0. Okay, that is not wrong. But this is a way of writing. Then what I do is I move whatever data is there in port 0, I move it to the accumulator. So once I have made my port 0 as input, now whatever data I am receiving from the external devices, whether it may be a switch, it may be a sensor, okay, whatever it is. So whatever data is coming from externally, it will be read by the port 0, and that data will be given to the accumulator. And from the accumulator, we are moving it to port 1. From accumulator, we are moving that data to port 1 and we are repeating. So we are keep on checking port 0. Oh, is port 0 receiving anything? Okay, he receives something. I'm sending it to the accumulator to port 1. Okay, you can't send data directly from port to port. There is no instruction to send data from port to port. I can't say port 0 to port 1. Invalid. Okay, invalid instruction. So you have to transfer it to a register, and from register to the second port which you are sending. So this is how the output of that program will look like. So if you notice, there is a switch connected to port 0. Now, do I require internal pull-up resistor when I'm using port 0 as input? No. Okay, I don't require an external pull-up resistor. So if you notice, my port 0 is shorted. So I have shorted all the pins and it is given to a switch. That switch is connected to 5 volts. So whenever the switch is pressed, I'll rerun this. Whenever the switch is pressed, the output is given to port 1. And you can see the LED is turned on. So this is a very simple program to use port 0 as an input. Coming to port 1, okay, port 1 can be used for input output. Okay, and if you notice, it is the same code. Okay, there is nothing different between the ports. Only thing, there will be no pull-up resistors in this case. So if you can go to this code, it does the same thing. So I'm moving 55 into accumulator. I'm moving the accumulator into port 1. I'm calling a delay. Now same change is there. I have used complement A. What is the meaning of complement A? Now your value of 55, right? 0, 1, 0, 1, 0, 1, 0, 1. If I complement it, what I will get? Complement is what? Whatever was 0 will become 1. So if you complement it, it will become 1, 0, 1, 0, 1, 0, 1, 0. So what is 1, 0, 1, 0, 1, 0, 1, 0? It is AA, right? So the same code just modified in a different way. So we have used a instruction called as complement A. So when I complement A, this is the value which I will get. And then I'm going to repeat this. Okay, small jump back means what? I'm going to jump back. Now this is your target. Okay, it's like a target. You go to this particular location. So go to back. Understood? So this is how you can perform the same function which we had done for port 0. Okay, the output of port 0 program. The same way it is written in a different way, just using complement. I have not put the output for that because it is the same as your port 0. Then port 1 as an input. Okay, so a little bit lengthier program. So nothing to worry. So when you're using port 0 as an input, first of all, we have to make it input. So how do I make the port as input? By writing FF into all the pins. Okay. Then whatever data is coming, I will store it into a particular register. Okay. Remember, you cannot transfer data from one port to the other port. Okay. Please keep this in mind. So I have to take the data, I have to store it in one register. Okay. I hope you all know that there are 8 registers, right? And there are 4 register banks. So you can choose any one. And these register banks are chosen by something called as PSW, Program Status Word Register. That is a special function register. So please go through your previous modules, okay, to understand what are registers, okay, how to select registers. So I'm going to store it into registers called a delay and then move the data into another register. Fine. So if you notice in this program, okay, first of all, we make port 1 as input, then transfer data from port 1 to A, from A to R7. So I'm storing it one register. So I'm storing data. So it's like I'm doing data collection. Okay. So I got some data from the sensor. I'm storing it in a particular value for further processing. Then I wait for some time. Then again I got another data from port 1. I will store it into another register. So I got 2 data and then I can do a program to compare both the data depending on what data I am collecting. Okay. Finally, I'll just go through this delay program. This is a 1 second delay program. Okay. Absolute call, what I was saying was, is a 11-bit okay, call. So I can call between 2k bytes of my memory. So I have my memory of 4 kilobytes of ROM. So I can just call between 2 kilobytes, from 0 to 2 kilobytes calling I can do. Calling meaning I'm going to a subroutine. So whenever I call a delay, I'm going to a particular subroutine. I'm going to execute that particular code and then I will be coming back. Okay. So whenever we call a subroutine, it will go to a particular area in the memory. That will be that particular location is given by the form of your absolute call when you do. Okay, it will take the address of the program counter plus the address of your absolute call, combine it together and then form a particular address, and then it will jump to that particular address. Okay, this is a little bit bigger topic that will be discussed later on. Okay, so if you notice over here, I'm doing some loops in order to create delays. Okay, so if I wait in one place for a long time, okay, I'm wasting time. So that is what we are doing. We are wasting time by creating loops. And one more point to note is DJNZ, okay, decrement and jump on no 0. It takes 4 machine cycles. So 4 machine cycles into 250, 4 machine cycles into 50. So this continuously goes on and creates a delay of 1 second. Okay, so if you just keep in mind this code, okay, of 1 second, how to create a 1 second delay. Fine. So that comes to the end of this module. Okay, the reference what I have used is from the book of Mazari, that is the 8051 microcontroller and embedded system using assembly and C. Thank you, students.